Good morning everyone. As we have already discussed association rules, how to generate association rule, worked out problems on it, now it's time to discuss a priori algorithm. So a priori algorithm is an algorithm which has basically two parts. The first step is to generate all the frequent item set, that is item set which are frequent in the whole transaction, and such items are discovered by finding out the support value of those items which is greater than or equal to minimum support. So those items which have support value greater than or equal to minimum support are considered to be frequent item sets. Second step is to find out all the association rules using these frequent items, and from these association rules select the confident association rules, that is the rules which have confident value greater than or equal to minimum confidence. So these are the two steps of generating a priori algorithm. First, to find out all the frequent item set. Second is to generate the confident association rules from these frequent item sets. Now let us discuss about two terms, that is size. Size means the number of items in an item set. If you have an item set I with 5 items, the size of the item set is 5. Likewise, the 5 item set is written as 5 hyphen item set. K item set means K is the size of the item set and K is the number of items in that item set. Next, frequent item set generation. Frequent item set generation means a set of items that appears in many baskets is said to be frequent. An item I is said to be frequent if its support is greater than or equal to minimum support, that we have already explained. Second thing, the whole frequent item set generation depends on closure property, downward closure property, or it is also known as a priori property. Downward closure property says when you have a frequent item set, all the non-empty subset of that particular set will be also having a minimum support. That is, here for example we have a frequent item set tea, biscuit, coffee. If it is frequent, in that case all the non-empty subset of this particular set, that is tea, biscuit, coffee, all the non-empty subset of this set is tea, biscuit, coffee, tea, biscuit, tea, coffee and biscuit, coffee, that has been shown here. They should also be frequent. If all of them are frequent independently, then this particular set is also frequent. That is the consideration. So that is what is explained in frequent item generation, and this property, that if all the non-empty subset is frequent, then that corresponding frequent set is also frequent. That property is known as downward closure property. Now this is one example which we have worked out in the classroom. So a PPT is already given and it is already been explained what it is. So it is a set of 7 transactions in which we have generated an association rule which is chicken close to milk, and its support is 3 by 7. Now the problem is to find out the item set, the non-empty subset of items, and also to find out the association rule which satisfies the confidence. So we have discussed it in another session. So we will move on. So this is the answer for the question. Now next is lexicographical order. Lexicographical order means the order in which the elements in the item set has to be arranged. That is, the elements in the item set should be arranged in such a way that if they are alphabets, then it should be in alphabetical order, and if they are number, it should be in ascending order. That is known as lexicographic order. Now next is candidate generation function. We have two steps of candidate generation function. First is joining step, second is pruning step. Joining step means we have to join the item set with itself to create different combinations of it. Like if we have ABC as frequent item set, we have to join them with themselves to create different combinations. That is AB, AC, BC. Like these are the different combinations. So this process is known as joining step. Here it explains it joins two frequent k-1 item set to produce a possible candidate C. The two frequent item set F1 and F2 have exactly the same items except the last one. C is added to the set of candidates. So how it has to look? In this example, we will discuss it clearly. What is joining process? At present, just understand it is the process of combining the elements of the frequent item set in such a way that we create all the possible combinations. When we combine the items of the frequent item sets, they are considered to be two frequent item sets as F1 and F2 with the last element different, and the newly created combined value is known as the candidate, which is added to the candidate set CK. Next step is pruning step. Pruning step is to find out the candidates which have the subset not frequent. That is, this step determines whether all the k-1 subsets of the C are in Fk-1. That is, whether all the subset of k-1 subset of the frequent item sets are also frequent. If they are frequent, the candidate is considered. If they are not frequent, they are not considered. So that is known as pruning step. Let us go through the example which will give you more clear idea about the joining and pruning process. Here we have a set of transactions T1, T2, T3 and T4 with items A, B, C, A, C, A, D, B, E, F. So this is the transaction set. Here 4 transactions. So first step is to go through the transactions and find out all the items. Here the items are A, B, C, D, E, F, and we also found the support value, that is 322111, in which here it is said that the confidence and the support should be greater than or equal to 50%. That means if it is 4, if the total number of transactions are 4, then at least it should be equal to or greater than 2. So in that case, here the only 3 values which has to be selected is ABC. So this is the first candidate set C1. In this, after pruning, that is, we have removed those item sets which are not frequent. After removing that, the candidate set, the frequent item set that we obtained is ABC. Now the second step is to combine, joining process. How to join? I would be joining ABC. I have to join ABC. So this ABC is arranged as 2 sets F1 and F2. So they are arranged as, so look at here, I have a set, my set is, what is my frequent item set is A, B, C, right? Now what I have done, I have arranged these items, the frequent item set, in such a way that it is 2 set. It is arranged as 2 different sets. F1, capital L, small f1, and F2 equal to this. Now what is the difference here? What we can see, that is, here the 2 sets are ABC. In ABC, it is the frequent item set. It is been arranged such that it is 2 frequent sets F1 and F2. F1 is AB, F2 is ABC. They are arranged in lexicographical orders, that is AB, ABC. Now the last element of F1, that is B, is not equal to A. B is not equal to C. That is, the last element of both the frequent item sets are not equal. B and C are not equal, and also B is less than C, right? So we have B not equal to C, and also B is less than C. That is alphabetic order lana. So these are the two conditions which has to be satisfied. It is being satisfied here. That's how we have arranged the A, B, C into two frequent item sets. Now I will combine it. How? I would always combine the element A to the element which is greater than A in the next set. So the first element, the element in F1 will be combined with elements of F2 which are greater than the element in F1. So A can be combined with B and C, A, B, A, C. B is combined with C, B, C. So these are the three frequent item set which we generated by the process called joining. Okay, so that is the process called joining, and this is how we do joining process. Now by joining we got A, B, B, C, A, C. Now what is the support value? It is 1, 1 and 2. 1, 1 and 2, and we know we need support value I at least equal to or greater than 2. So the frequent set is which has more than means which satisfied that frequent condition is AC, and that is the process called pruning. I have pruned it, I have removed those which are not frequent, and I have got the value AC. Now further AC cannot be again combined or anything. Whatever we do, AC remains AC. So no need of doing any other action on AC. Now the two association rules which could be generated using AC is AC and A to C and C to A. Now I have calculated the support value, the confidence value, and I have found that the confidence value of A to C and C to A is 66% and 100%. That's how we proved that these two rules have minimum confidence which is equal to or greater than 50%. So thus we have generated the two possible rules. So this is the association rule. This is the a priori algorithm which has been explained now with an example. This is the first a priori algorithm for finding frequent item set. This is the second step to generate the candidate function. So I will be discussing this algorithm with an example in another video. Up to this, hope it is clear. Thank you.